Hi guys, today we will solving freedom trail problem. So it's lead code problem number 514. I think you have already read the question. I'll just go on and discuss what this question is saying. So uh, the question, what it's trying to say, it's trying to say कि you have a dial. This dial is consisting of some character which are given in form string somewhere. Okay, and on the top of this dial you have a pointer at 12 o'clock. So and there is also a button. So whatever character is pointed by this pointer at a given time, and at that time when you press the button, that character is inserted in my output string. Let's say this is my output string, then A is inserted. Now I can also rotate this dial either clockwise or anti-clockwise direction. Let's say I choose to rotate it anti-clockwise. So in that case, A will come here, B will come here, and C will come here. Now if I press enter, I'll get here B, and so on. So it's up to me. I rotate it clock or anti-clock or whatever I like. So that's how the dial is working. The another thing given in question is you are giving a input a string. Let's say, for example, A, B, D. Now the whole question is to create this string by rotating this dial. Okay, and also one more thing, the most important thing, that is whenever you rotate this dial, you use a 1 point. Okay, whenever you press this button, you use a 1 point. So either you rotate or either you press the button, you are using 1 point. So let's say I have to create ABD. Let's say how many points we are going to use. First of all, it's already at A. So we don't have to rotate it. We have to just press the button. One, A is inserted. Now we have to rotate it to get the B. We can either do it clockwise or anti-clockwise. Let's say we do it by rotating it anti-clockwise. Now B comes here. For rotating we use 1. For inserting B, we used 1 point. Now D. Now in this scenario, B is here, C is here, and D is here. So now we have to rotate it twice. One, two. So rotation 1, 2. Then for pressing the button 1, and we'll get D. So we are totally using 6 points for printing ABD. Correct? Yes, correct. So now the question is to minimize these points. For any string to be printed, we have to minimize these points. That's the question. That's the overall question. So how can we do this? The first thing is clear. We have to find the closest next character. Let's say my string is BC. So I have to find the, and currently I'm at A. So I have to find the closest B. But the B can be present both the sides. Let's say in this scenario, here we have C, here we have B. Correct. So in this scenario, when I'm trying to find B, it's here and also here. Now you're going to say this one is closest. Why I'm checking this one? The reason is, let's say I take this B closest, but next time I have to use, let's say, another character. Let's say it was not C, it was F. Let's say assume it's F. After B, I have to go for F. So I have to go this way. So there will be 1 and 2 steps, total 2 steps involved. But if I have chosen this B, only one step is involved. In this situation I'm creating, in that you will get the same points, but I'm trying to tell you that if there can be multiple situation in which choosing the bigger option first can give you the overall minimum result. That's a very simple scenario that I think you have already done many DB problems. So that's a very basic scenario that you know, that you have to choose. You have to check for both, from left and from right. Correct. So for left and right, we are going to choose the minimum. Okay, for both left and right. By what I'm trying to say, for both, I'm trying to say, let's say here also there was a B. So I have to check only this closest B in left and closest B in right. I don't have to check for this one because that doesn't make sense. Correct. I have to just check both at the edges. Okay. So what's happening now? What's happening is, first I was at A. I have to create a string BC. Nothing. So I'll check for B both the sides, left and right. So here I'll make one move, one plus. Then I'll have string B in my input. Correct. Then from B, I'll move to left and go for C. Then press the button. One, one. So total step how many? Four. This one plus one two goes here. One plus one two goes here. So what we are doing, we are creating a tree and we are pushing the minimum value from the leaves to the top. Correct. Everywhere we will be getting values from the leaves and we will be pushing minimum values to the top. So at the end, at the top, I'll get my minimum answer from everywhere. Correct. So now there can be multiple situations. The first is, let's say my ring is A B C D, A B C D C B, and my key is A B and D. So first scenario is, I'll have an index I and J. I will be pointing to index for the key for the ring, sorry, and J will be pointing for the key. So if ring of I is equals to ring key of J, sorry, the character of K at J index. If both are same, so in that case we have to just press the button and solve further. Correct. For pressing button one and then solve further. And solving further, this key, this ring will be at the same index I, but index comma key will be moved one step. I'm sorry for the cursor. I was having problem with my pen, so I'm using the mouse. So that's one scenario. The other scenario is I went to the left as to the right, but I end up at same index. In this case, D. Correct. In that case, I don't have to plant the tree both the sides. I don't have to go for the checking the tree both the sides. Because both the sides, left and right, are same. Both are pointing to the same index. Correct. So what I'm going to do in that case, I'm going to find this distance here or here. This distance, whichever is minimum. As this index is same from left and right, so I will check the distance, this one and this one. Which distance is smaller? D1 comma D2. Whichever distance is smaller, this distance plus 1. This is why these are the points to move the dial. Minimum of this distance plus 1. This will give me the answer to print this D. Plus solving further, which will be this new index. Not the I. In previous it was I. This time new index. New I comma J plus 1. I'm really sorry for my cursor, guys. Really sorry. Okay, this is one scenario. Now let's the third scenario in which both index are different. This one and this one. So while searching for this scenario, searching for this C, what I am going to do? I am going to, let's say, searching for a string C and D. I'm searching C from A. So while searching C, next present in my right hand side, while searching, I'll take a pointer distance d1 and I will increment it. correct? So for searching this, my D will be 2, 1, 2, and for this left hand side it will be same D, 2 will also be 2. Both the sides I will increment while searching these numbers. So for this character C, my answer will be 1 plus D1 plus solving for the this time my index is this new index for this. So I'll say left index li comma j plus 1. I'm speaking guys, this is really bad. I'm really sorry. Left of I plus j plus 1 comma sorry comma j plus 1. And for d2 it will be same, just d2 here, correct? And out of these two, the minimum will be the answer, minimum. So I'll send this minimum to my calling function in recursion. So I hope you're getting the solution. We'll just code it and then you will get it better. Okay, I'll just reset the code so we can start from scratch. I'm making global variables for the sizes. So one is length for ring, another is length for key. Length of ring is, and then what we are going to solve, what we are going to solve, ring, key, and our indexes. Both will be zero at starting. Initially, we are not writing DP. I'll add the DP later on. Currently, we are writing the normal recursive solution. Taking example here. So this is my ring. This is my key. First of all, my both the index will be pointing at zero. Here at G. Here at also at G. Correct. First of all, we will write the edge cases. So if I is greater than equals to I is pointing ring, so an of ring, or j is greater than equals to n of ring, we'll just return zero in that case. Now first case that I was talking about, that we are searching for G and we are already at G. Correct. So I'm saying ring of I is equals to E of J. In that case, we don't have to rotate, we have to just press the button. For pressing button, we will use 1 point. So 1 plus solving for the solve a ring key. Index is going to be same as we have not rotated the key, but we are going to the next index for our string. This is the one scenario. Another, now we will check for the character. Now this means that we have, like, this is the another scenario. I have pressed the G button. Now I have to find D. So I have to find the both the sides, here as well as here. This G is added at the back of the string as it's rotated. Correct. It's a rotational layer. Correct. So I'll search both the sides. So I'll take two indexes, left index, which will start from I, right index, which will also start from I. As starting index is going to be same. Correct. Now also find the distance, how much we have rotated using two pointers, distance one, distance two, for both left and right. One is for left, two is for right. Simple. I'll check until I'll rotate my dial left until I find character in my ring same as character at my key. So until ring of left I is not equals to key of, till then what I'm going to do, I'm going to rotate it left. As it's a rotating area, you can write a modulus function, or I can simply write if left of I is less than 0, on it to this index, correct? I'm at G, I'm doing minus minus, I got minus 1 index. Minus 1 is not possible as it should be this one, which is length minus 1, correct? And also do distance plus plus. Same I'm going to do for my right side, but in this case just the plus instead of x. In this case, it will not be less than 0, it will be equals to n of ring. In that case, we have to change it to 0, just opposite of left, correct? And distance 2 should be plus plus. Now, after this, I had two possible ways, two possible solutions. First was if left of I is equals to right of I. So that means I have, let's say from G I was searching I. So it's same index is going to be same for this. In this scenario, what I'll do, I'll return how much I've rotated. I could have rotated both left hand side and right hand side for the same index, correct? So minimum of D1 and minimum of distance 2 plus 1 for pressing the button plus solving further. This time index is going to be this new index which is same left of I with whether I write left or right, it's same. So ring key left of I comma j plus 1. Simple. Scenario is over. Another scenario is both were different. Both were different. Both. Let's say I was at G but I was searching for D. So I could have chosen this D or this D from left or right. Okay, so in that scenario I have two answers. For let's say I'm writing answer for left. For left, my answer will be distance plus 1 plus solving from here. Ring key left eye as now my new index is left eye 0 plus 1, or another answer left arm will be, sorry, it's distance 1, it's distance 2. Oh, I'm really sorry. Hmm. Where was that? Yeah, right eye 0 plus 1, and I have to return minimum of both, and this should give me the answer. There might be some syntax error. We'll check. Okay, so first scenario, both are same. Second scenario, both were different. Oh, sorry, the character was different, but the index was same. Third scenario, character was different, the index was also different. Okay, let's see. What the okay left eye? Where, where? Sorry, I told you I sometimes I do multiple syntax errors. Really sorry. Okay, I'll just pause the video and sorry I did multiple syntax error. I corrected them. It was just about small r, capital R. That's were all the problems. So this is the solution, but we haven't added DP in it. If I try to submit this, I'll get TLE definitely. So now we will add. First of all, we see the solution again, and then we will add DP. So the solution is simple. We are starting from 0 index for both, and we are checking both left and the right side. Okay. So this the breaking condition. If my current ring of I is same as J, I'll just press vote button and then solve further. Otherwise, I'll check both left side and right side. Try to find both. For left, I'll check the distance. For right, I'll also check the distance. If both the index come out to be same, I'll just return minimum of distance 1 or 2. Press the button 1 and then solve further. If both are different, I'll solve differently. It's same. See, it's same equation, same thing, differently. Here it was just minimum of both in this condition, and here I am doing it separately, distance one, distance two. Okay, and then return the minimum. Correct. So here I am creating the branch here only. This is the only situation in where I am creating the branch. So for my problem, when I'm at the same key for the same ring, I'm not creating any branch. When I have only one index, I'm not creating the branch. I'm only creating the branch when I have character both the sides which have different indexes. Correct. Only one chance. So now we will add the DP into it. The size of DP is we'll check 100. So we'll create a DP of 101 to be there. We will initialize it with -1. Definitely. Obvious thing. Correct. DP -1 size of D. Now we'll check the basic, like how we write the DP, basic thing, nothing more, nothing much. Basic stuff. Don't have to even worry about it. IJ. That's not equals to -1. We'll just return DP. You don't have to even think about it. It's just adding DP whenever you want. Here we have two indexes I and J, so I'm creating DP for both I and J. Simple solution. You don't have to think why you're getting, like, for what indexing you are getting DP, how you're getting DP. I'll tell you how to get a DP, but it's a quick solution. So you can just see how many parameters you have. In this scenario, we have two parameters. So you will create a DP with two parameters. I and J. Simple. So while returning, I'll just simply write DP of IJ. If I'm storing the value first in DP. Correct. Simple. So while every time returning, I'll just write this. Simple. I'm returning here. I'm returning here. So I've added the DP now. I'll just run the code, then submit. Got error for what? Okay, we got the error for sign integer overflow. So let's say we are where we are getting our overflow value. It's definitely somewhere here where we are adding one to our solution. Okay, so let's solve this. So clearly, we can see that only possible place to overflow the value is here. It's integer, and I'm solving it here. So the solution might also be the maximum value possible. So instead of int, I'll change it to, or I can just simply write unsigned to increase the value, to increase the capacity. I forgot to use this test case. It should go up again. So somewhere else also this is happening. Distance 2 can't be overflowing. How can this be possible? This thing can't just overflow. It can't. The length here is just 5. The maximum thing it possible is 5. 4 actually. The maximum value it can get here in this test case is 4. How can this be overflowing? How? Let's check. Let's check it. 0. This is absurd. Undefined behavior. How can this value even be coming for this? Let me check the DP. There is no point for DP. How can this overflow? Oh, let me just check the value for this. This is for the upside, like I'm telling you, this is upside. This shouldn't be happening. How can the value for this can go so high? So high. How? The maximum value possible for this should be 4. Let's say at you are at A and you are searching for E, so maximum value is 4. Correct. Given A, E is present. It's for printing. For printing, obviously, it's going to be 50, 60. And 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, oh, I'm really sorry. I have written my son. It should be the limit. Oh, freak. Sorry for this, guys. Just wasted your time. Submit. Okay, here you go. Works. I'll be posting this solution in the description. You can try it out. Thank you.